The distance between the Earth and the Moon is roughly 380 million metres. This is quite a big number. In maths and science, when we have really big numbers like this, we have another way of writing them down that's often more convenient. So we could write this number as 3.8 times 10 to the power 8 metres instead. The number on the top here is known as an ordinary number, whereas the number on the bottom is written in standard form, and that's the topic for this video. Let's take a closer look at this number in standard form. There are two parts to a number written in standard form. Firstly, we have this number here, which is always a number between 1 and 10, although it can't be exactly 10, but it can be 1. Then we multiply this by an integer power of 10. By integer, I mean a whole number. So 10 to the 8 is okay, but 10 to the 2.6 is not, because 2.6 is not an integer. So the following numbers are all written in standard form. You can see the first number is always a number that's between 1 and 10, but not 10 exactly. And then they're always multiplied by an integer power of 10. Notice how negative numbers are still integers, so negative 2 is an integer. These numbers, though, are not in standard form. So 16 times 10 to the power 4. That's because this first number here is greater than 10. Remember, it needs to be between 1 and 10, although not 10 exactly. This number's also not in standard form, because the first number here is less than 1. This number is also not in standard form, because this is not an integer power of 10. 1.5 is not an integer. You need to know how to convert an ordinary number into standard form, and we're going to look at that now. So let's start with the number 7,000. The number in standard form comes in two parts. The first part is a number that's between 1 and 10. So looking at this number, we could use the number 7. Then we need to multiply this by a power of 10. To work out this power of 10, we're going to temporarily place a decimal point into the number 7,000 so that it actually reads as 7. So this is 7.000, which is just 7. Then we need to see how many times we multiply this by 10 to get to 7,000. Well, if we multiplied 7 by 10 once, we'd end up with 70. If we did it a second time, we'd end up with 700, and a third time, we'd end up with 7,000. So we multiplied by 10 3 times, so the power of 10 is 3. So 7,000 is 7 times 10 to the power 3. Let's try a second example. So this time 420,000. So we need the number that's between 1 and 10. This time, looking at the digits we have, we're going to need to use the 4 and the 2. So the number will be 4.2. And then we need to multiply this by a power of 10. So let's place a decimal point into the number so it reads as though it were 4.2. And then we'll see how many times we need to multiply this by 10 to get 420,000. So multiplied by 10 once would be 42, a second time would be 420, a third time would be 4,200, a fourth time, and a fifth time. So we multiplied this by 10 5 times, so the power of 10 is 5. I want to point out a really common mistake that people make at this point. People often assume that the number of times you multiply by 10 is how many zeros the number has. And whilst this works for 7,000, there are 3 zeros and the power was 3, it doesn't work for the next example. There are 4 zeros there and the power was 5, so that's not a rule you want to learn. Let's try a few more examples. So 61,400. We need to use all of these digits 6, 1 and 4 to create our number between 1 and 10, so that will be 6.14. Then we multiply this by a power of 10, we place the decimal point so it reads as 6.14, and we see how many times we need to multiply it by 10. So it's 1 time, 2 times, 3 times, 4 times. So it's 10 to the power 4. What about if we had this number here, 320? So this time we've got to use the digits 3 and 2, so it'll be 3.2. And when we multiply this by a power of 10, let's place the decimal point in so it reads as 3.2, and this one we only need to multiply 1 time and 2 times. So it's 3.2 times 10 to the power 2. And we'll try this one as well, 504,000. So this time we want to use the digits 5, 0 and 4. Basically, you must use all of the digits until you get to just zeros. So this one will be 5.04 times 10 to a power, and we'll place that decimal point in so it reads as 5.04, and we multiply it once, twice, 3 times, 4 times, and 5 times. So it's 5.04 times 10 to the power 5. You also need to be able to do the reverse process. So if you're given a number in standard form, you need to convert it back to an ordinary number. Let's look at how we do that now. So we're going to start with this number that's in standard form, 5 times 10 to the power 6. You could think of this as 5 multiplied by 10 6 times. So that's what we're going to do. If we multiply 5 by 10 once, we get 50. If we do it a second time, it'll be 500. A third time would be 5,000. A fourth time would be 50,000. A fifth time would be 500,000. And a sixth time would be 5 million. So 5 times 10 to the 6 is 5 million. What if we did 7.9 times 10 to the power 4? So this time we need to multiply 7.9 by 10 4 times. If we multiplied 7.9 by 10 once, it would be 79. A second time would be 790. A third time 7,900. And a fourth time would be 79,000. Let's try some more. So 8.53 times 10 to the power 3. So we're going to multiply 8.53 by 10 3 times. If we did it once, it would be 85.3. A second time would be 853. And a third time, 8,530. What if it was this one? Well, this time we're going to multiply 9.04 times 10 8 times. So if we did it once, we get 90.4. A second time, 904. And then a third, fourth, fifth, sixth, seventh, and eighth time. So we end up with this number here, which is 904 million. There are some other numbers that we also need to be able to write in standard form. In science, you've probably learnt about atoms. Atoms are incredibly small. In fact, the width of an atom is roughly 0.0000000001 meters. Just like we use standard form to write very large numbers, we can also use standard form to write very small numbers. This one would be 1 multiplied by 10 to the power negative 10. When we have a negative power of 10 here, you could imagine that we're actually dividing it by 10 a total of 10 times. So it makes the number very, very small. Let's have a look at how we can convert some small numbers into standard form. So we're going to start with this number here, 0.008. We need to start with a number between 1 and 10 again, so that's going to be 8, and then we multiply this by a power of 10. Since this number is very small, we're going to use a negative power of 10. We want to place that decimal point in again, so this number reads as though it were 8. So we place the decimal point after that final 8. We're now going to divide 8 by 10 as many times as we need to, so that we end up with 0.008. So if we divide 8 by 10 once, it would be 0.8. If we did it a second time, it would be 0.08, and if we did it a third time, 0.008, the number we're after. So we divided 8 by 10 3 times, so this will be 8 times 10 to the power negative 3, and it's negative because we divided rather than multiplied. Let's try a second example, so this time 0.039. If we look at these digits here, we're going to need to use both of them, so the number from 1 to 10 will be 3.9, and then we multiply this by a power of 10. So we're going to place our decimal point so the number reads as though it's 3.9, and see how many times we need to divide it so the decimal point lands in the right place. If we divide it by 10 once, it will be 0.39, and a second time would be 0.039. So we divided this by 10 twice, so it will be times 10 to the power negative 2. Let's try another one. So this time 0.000044. Using these digits here, the number between 1 and 10 will be 4.4. Then we multiply this by a power of 10. Let's place that decimal point in so it reads as though it's 4.4, and we need to divide it by 10 once, twice, 3 times, 4 times, and 5 times. So this one is 4.4 times 10 to the power negative 5. Let's do one more, so 0.615. So we need to use all of these digits here to create that number between 1 and 10. So it's going to be 6.15. And then we multiply this by a power of 10. If we place the decimal point in so it reads as 6.15, and then divide it by 10 until it ends up in the right place, well, this time it only needs to move once. We divide by 10 once, so it's times 10 to the power negative 1. Now, just like when we had very large numbers, you also need to be able to do this process in reverse. So if you're given a number in standard form, you need to turn it into an ordinary number. Let's look at how you do that now. So we're going to start with the number 2 times 10 to the power negative 4. You can think of multiplying by 10 to the power negative 4 as dividing by 10 4 times. So we're going to start with 2 and divide it by 10 4 times. If you divide 2 by 10 once, you get 0.2. If you do it a second time, it's 0.02, a third time 0.002, and a fourth time 0.0002. Let's try another one. So this time we need to do 8.5 and we're going to divide it by 10 3 times. So 8.5 divided by 10 once is 0.85, a second time 0.085, and a third time 0.0085. Now let's try this one, 1.79 times 10 to the power negative 5. So we'll start with 1.79 and divide it by 10 5 times. So if we divide it by 10 once, 0.179, a second time 0.0179, a third time 0.00179, a fourth time 0.000179, and a fifth time. We get the answer 0.0000179. Let's try one more. So 6.4 times 10 to the power negative 1. Well, this time we only need to divide 6.4 by 10 once, which is 0.64. Sometimes exam questions will ask us to put some numbers in order that are written in standard form. Let's have a look at a couple of examples of these. So here we've been asked to put the numbers in order of size, starting with the smallest, and these are the numbers we're going to do. So the way I'd recommend doing this question is converting each of these numbers from standard form to an ordinary number, just like we practiced before. So 3.8 times 10 to the power 3 is 3.8 times 10 3 times. So 3.8 times 10 once is 38, a second time is 380, and a third time is 3,800. 6 times 10 to the power negative 2 is 6 divided by 10 2 times. Remember, when we have a negative power, we need to think of it as being divided by 10. So, divide it by 10 once is 0.6, and a second time 0.06. 1.92 times 10 to the power 4 is 1.92 times 10, a total of 4 times. So if we times it by 10 once, we get 19.2, a second time is 192, then a third time, and a fourth time. And finally, 4 times 10 to the power 3 is 4 times by 10 3 times. So times by 10 once is 40, a second time is 400, and a third time is 4,000. It's now much easier to compare the size of these numbers. So you'll be given an answer line to write the answer on, and we're going to do that now. So we're going to start with the smallest one, which is 0.06, but we must write what that was in standard form, because those were the numbers we were asked to put in order. So this was 6 times 10 to the power negative 2. I'm going to tick this one off so that I remember that one's done. So now looking at the remaining 3 numbers, the smallest one is 3,800, which was 3.8 times 10 to the power 3. So let's take that one off. The next one is 4,000, which is 4 times 10 to the power 3. So if we take that one off, the last one must be 19,200, or 1.92 times 10 to the power 4. Let's try a second example of this. So this time we're going to put these numbers in order, starting with the smallest. Now you may notice that some of these numbers are not written in standard form. For example, the second number, 28 times 10 to the power 2, because the number 28 is bigger than 10. This is something that has happened in past exam questions, so it's something to watch out for. It's not wrong because they're not in standard form, we just need to be careful. So we're going to put these numbers in order, let's convert them to ordinary numbers first. 2.7 times 10 to the power 5 means 2.7 times 10, a total of 5 times. So let's times it by 10 once, which is 27, a second time, a third, a fourth, and a fifth. Now onto the second one, we've got 28 times 10 to the power 2, so that's 28 times 10, 2 times. So if we take 28 and times it by 10 once, that's 280, and a second time, that's 2,800. And on to the next one, we've got 0.275 times 10 to the power 4, so times by 10 4 times. So let's times it by 10 once, which will be 2.75, a second time, 27.5, a third time, 275, and a fourth time, 2,750. And on to the final one, we've got 0.29 times 10 to the power negative 2. Remember, if it's a negative, we're going to divide by 10. So we're going to divide it by 10 2 times. If we divide it by 10 once, we get 0.029, and a second time 0.0029. So we're now ready to put these in order again. We'll choose the smallest one, which was 0.0029, or 0.29 times 10 to the power negative 2. And let's take that one off. Then for the next smallest one, 2,750, or 0.275 times 10 to the power 4. And if we take that one off, and on to the next one, 2,800, or 28 times 10 to the power 2. And if we take that one off, the final one, 270,000, or 2.7 times 10 to the power 5. Now you might be thinking we need to write these numbers in standard form on the answer line, but we don't need to. We just need to write them as they were given in the question. Another thing you need to be able to do is calculate with numbers in standard form. So we need to be able to add, subtract, multiply, and divide numbers that are written in standard form. Let's have a look at some examples of these. So we're going to do this question here. 3 times 10 to the power 3 multiplied by 2 times 10 to the power 5. And we're asked to give the answer in standard form. So one way of doing this is taking the question and rewriting both of these numbers as ordinary numbers. I'm not going to explain this process anymore because we've done it several times in this video. So 3 times 10 to the power 3 is 3,000, and 2 times 10 to the power 5 is 200,000. So we're just multiplying 3,000 by 200,000. To do this, we can do 3 times 2, which is 6, and then we've got 1, 2, 3, 4, 5, 6, 7, 8 zeros, so 6 followed by 8 zeros, or 600 million. The question did say to give the answer in standard form though, so we'll convert this back to standard form, and once again I'm not going to explain this anymore in this video because we've done it several times. So this will be 6 multiplied by 10 to the power 8. So this is the answer to this question. Now this question can be done a lot faster by taking a shortcut, and I'm going to show you that now. So if we take the question once again, here we just have lots of numbers multiplied together, and because of that we don't actually need these brackets at all, and we can reorder these multiplications. So we could write it as 3 times 2 times 10 to the 3 times 10 to the 5. That'll give the same answer. If we look at 3 times 2, well that's obviously just 6. And then if we look at 10 to the 3 multiplied by 10 to the 5, we add the powers here. So 3 add 5 is 8. So this is 10 to the power 8. So we're multiplying 6 and 10 to the power 8, so we end up with 6 times 10 to the 8, which was exactly the answer we got before. So this is a much faster approach of multiplying numbers. Let's try that with another example. So for this one, we're going to multiply these two numbers in standard form. We're going to start by multiplying the 2 and the 4.4. 2 lots of 4.4 is 8.8. Then we're going to multiply 10 to the 4 and 10 to the 10. Here we add those powers, so it's 10 to the power 14. And that's the answer, and it's in standard form. Let's try a third example, so this one's going to be a tiny bit different. We'll use the same strategy, we'll do 3 times 9, which is 27, and then 10 to the 3 times 10 to the 4, if we add those powers, we get 10 to the power 7. Now this one creates a problem because the question says to give your answer in standard form. We know this number's not in standard form because this first number here, 27, is greater than 10. We would much rather that number said 2.7. So that's exactly what we're going to do. To turn the 27 into a 2.7, I must have divided it by 10. But you can't just divide numbers by 10 with no consequence. If we're going to divide the 27 by 10, we should multiply the 10 to the 7 by 10 to keep this the same size. If we divide by 10 and times by 10, we end up where we started. So 10 to the 7 multiplied by 10 is 10 times 10 times 10 7 times, multiplied by another 10, so that's now 10 8 times, so 10 to the power 8. This is now the same number, but written in standard form, and that's the answer to this question. Let's try another example like this one. So now we're going to do 7 times 10 to the power 8 squared. When you square a number, you multiply it by itself. So this is 7 times 10 to the 8 multiplied by itself. Now we just apply the same rules as before. So we need to do 7 times 7, which is 49, and 10 to the 8 times 10 to the 8, and we add those powers, 8 plus 8 is 16, so it's times 10 to the power 16. This is not in standard form again. We can't have 49 because it's bigger than 10. We need it to say 4.9, so we're going to divide it by 10, which will give us 4.9. Because we divided this by 10, we'll multiply the 10 to the 16 by 10, which means we get an extra 10, so there are now 17 10s multiplied, so 10 to the power 17. And that's the answer to this question. Now that's a lot of multiplying numbers in standard form. Let's next look at dividing. So we're going to do this number divide by this number. We're going to use a similar strategy to when we multiplied. So with the 5 and the 2 here, rather than multiplying them, we're going to divide them. 5 divided by 2 is 2.5. And then we will also divide the powers of 10. So 10 to the 6 divide by 10 to the power 2. When we multiplied, we added the powers, and when we divide, we subtract the powers. So we need to do 6 take away 2, which is 4. So this is times 10 to the power 4. Notice how it's still a times in the answer and not a divide here. That's another common mistake that students sometimes make. This number's in standard form, so that's that question finished. Let's try another one. So this time 9 times 10 to the power 5 divided by 3 times 10 to the power negative 2. Let's use the same strategy. So 9 divided by 3, which is 3. And then 10 to the 5 divided by 10 to the power negative 2. So here we need to subtract the indices, but you have to be careful with negative numbers. We need to do 5 subtract negative 2. And when you subtract a negative number, that gives you the same result as if you added the positive number. So that gives us the same answer as 5 plus 2, which is 7. A really common wrong answer to this one will be using the power 3, but that would be 5 subtract 2, not 5 subtract negative 2. So the power will be 7, so it's 3 multiplied by 10 to the power 7. That's in standard form, so we finished. Now let's try this question. Now this one does look a little bit different, but it's still a division. When you write a fraction, you're really just saying the top number divided by the bottom number. So this is the same as 3 times 10 to the 8 divided by 6 times 10 to the power 3. But as it happens, it's actually easier to think of this question in a fraction form. So let's write it out. And we're going to do what we did before, divide the numbers. So 3 divided by 6. But if you write 3 divided by 6 as a fraction, that will simplify quite nicely to 1 over 2, which is a half. A half written as a decimal is 0.5. So the first part of this number is 0.5. Then we can divide these powers of 10. So we need to do 10 to the 8 divided by 10 to the 3. So we need to do 8 subtract 3, which is 5. So this is times 10 to the power 5. Now unfortunately, this number is not in standard form. We need that first number to be between 1 and 10, and 0.5 is below 1. So what we're going to do this time is multiply it by 10. 0.5 multiplied by 10 is 5. So that's now between 1 and 10. But as before, we can't just make this change without any consequence. The number would be 10 times bigger. So to balance that out, we're going to divide the 10 to the 5 by 10 as well. Now when you divide it by 10, there'll be 1 fewer 10s, so it'll actually be 4 now. So it's times 10 to the power 4. This is now in standard form, and that's the answer to the question. Now let's try one more of these. So we're going to do 1 times 10 to the power negative 7 divided by 4 times 10 to the power negative 2. I'm going to keep this in its fraction form once again. So if we begin with 1 over 4, we could think of this as a fraction, as 1/4, and 1/4 as a decimal is 0.25. Then if we move on to the powers, we've got 10 to the power negative 7 divided by 10 to the power negative 2. Here we need to subtract those powers, so we need to do negative 7 subtract negative 2. Once again here we need to be really careful with negatives. We're subtracting a negative number, which is the same as adding the positive version of that number. So this gives the same answer as negative 7 plus 2. Negative 7 plus 2 is negative 5. So this is also equal to negative 5. So we end up with multiplied by 10 to the power negative 5. Once again, this is not in standard form because that first number is too low. It needs to be greater than 1. So we will multiply it by 10. This will give us 2.5. If we've multiplied this by 10, we should divide this by 10, which means the power gets lower by 1. Now you also need to be careful here. If you reduce negative 5 by 1, you go down to negative 6. So this is times 10 to the power negative 6. If you find that difficult to follow, just imagine a number line. If you were on negative 5 on a number line and you subtracted 1, you would move to the left 1, which gives you negative 6. And that's in standard form now, so that's the answer to the question. Now let's have a look at what happens when you add and subtract numbers in standard form. Now whenever you add and subtract numbers in standard form, I'd recommend that you do convert these to ordinary numbers. So 5 times 10 to the power 4 is 50,000, and 2.9 times 10 to the power 3 is 2,900. If you add those together, you get 52,900. This question asks us to give the answer in standard form, so if you convert that back, it's 5.29 times 10 to the power 4. Let's have a look at another one, and this time the question's slightly different. It does say give your answer as an ordinary number. So let's take the question and convert them to ordinary numbers first. So we've got 4 times 10 to the power 2, that's 400, and 1.6 times 10 to the power negative 2, which is 0.016. Since this wants us to give it as an ordinary number, we just add those together. So it's 400.016. The same idea applies when you subtract. So in this one, we're also asked to give it as an ordinary number. So let's write out the question. Convert them into ordinary numbers. So 7 times 10 to the power 5 is 700,000, and 3 times 10 to the power 2 is 300. If you subtract these, we get 699,700. Thank you for watching this video. I hope you found it useful. Check out the one I think you should watch next, subscribe so you don't miss out on future videos, and why not try the exam questions in this video's description.